All right. So yesterday in our class, our chemistry class, network came so hard on us, total interruption that we could not, continue the class. But of course, like I have always said, GMAT 41, we may continue to face challenges, especially with respect to network, as regards the work I do online here. But the truth is, we are never frustrated. GMAT 41 is unstoppable. And so, although we were able to handle some parts of this class yesterday, I had to quickly come on live this morning so we can conclude the remaining part with regards to why a student should give serious attention to the concept of valence electron. So just as a quick reminder, in our yesterday class, I explained the concept of valence electron, stating that it is the number of electrons in the outermost shell of an atom, of an element, okay? Number of electrons in the outermost shell. I actually wrote a definition here because I had wiped, I had actually explained this concept of how to identify metals using the knowledge of valence electron before the network interfered. One thing was that unfortunately, I did not check from the camera to know whether the network was still holding on or not, so I could boost. I did it. Perhaps because yesterday something really made me so sad with regards to the way, the academic system, education system is being messed up a bit by those that are supposed to be championing it, So that's it. Therefore, this morning I would have us finish up what we're meant to learn in that yesterday's class, okay? I'll have us complete what we're meant to learn in that yesterday's class. Once you join the class, hit the like button, all right? And then subscribe if you have not subscribed yet. Turn on the notification bell and select all. Take note, subscribe if you are yet to subscribe to this channel. This is a full online school. I'd always say this. After subscribing, go ahead and turn on the notification bell. If you click on the notification bell, a drop-down menu will show. Select all. Select all. These things are free of charge. Is that okay? The reason is whenever I come on live or I upload any content, you will be the first person to be notified by YouTube. For example, I just came on now live to complete our class yesterday. Today I wasn't supposed to be live on this channel, but I had to do it to complete our class yesterday. If you had not subscribed, if you even subscribed and you did not turn on the notification bell and select all, you won't receive this notification. You see? So subscribe and turn on the notification bell. So even if maybe for one reason or the other you are not able to connect live in real time as I am on now, by the time we are done, a copy of the lesson will be made available so you can, when you receive that notification, of course, you're going to receive it once I am on live, real time. If you're unable to take the lesson much later, at your convenience, you can take it. All right, please, let us get back to business quickly. Is that okay? So we define valence electron as the number of electrons in the outermost shell of an element, okay, or in the outermost shell of an atom. So you draw an atomic structure of an atom. The electron in the last shell is what we call the valence electron. The electron on the valence shell is what we call the valence electron. And then, of course, I went ahead to draw this atomic structure, okay? It was here that I defined the concept of valence electron, after which we brought out 4 atoms and drew their atomic structures. So I was to use this atomic structure to now see one application or teach you one application of valence electron, which will now cover part 1 of this class before that network interrupted. In fact, when I wrote from here down, from here, identifying nonmetals up to this point of identifying periods of an element, the network and its people have actually caused damage, but I did not take it. So as the class is on, once in a while I'll check on the camera to be sure that the network is intact. Since I have the note here on the board, I'll just go ahead to explain, okay? We've talked about drawing atomic structure at least, then the network didn't disturb, so that's part 1, all right, explains all of that. This class is going to be part 1A. So we move on. I remember that we were talking about how to identify metals from the knowledge of valence electron. If you have not taken that lesson, please, at the end of this, make sure you go back to take it. The video lesson is already available on the live section of this channel. So with the knowledge of valence electron, a student easily gets to know an element that is a metal, and of course an element that is a non-metal. So here we have this short note on the board identifying metals from valence electrons. So we said that if the valence electron of an element is either 1 or 2 or 3, that element is a metal. Once again, an element whose valence electron is 1 or 2 or what? 3. That element is what? A metal. So by the time an examiner asks you maybe a list of elements, which one is a metal, if you are aware of the valence electron, which is very simple, because from atomic structure and electronic configuration, you already know valence electrons, then you can easily answer that question in a twinkle of an eye, just within a second, you can answer the question. So always remember this. If valence electron is 1 or 2 or 3, such element is what? A metal. Okay? Good morning all and welcome to join the class Core Clash. Hello bro, hello, good morning and welcome to the class. Is this class of topic 11 or 9th? Alright, this class specifically, the truth is, it targets grade 10. Because that level, grade 10, in Nigeria here we call it SS1. That is the class where the concept of atomic structure is being introduced. But please, dear friends, let me tell you something today. Let me tell you something, and I want you friends to be aware of it. You should understand the scheme of work, the curriculum that is being run by our education system. Okay? And I think it happens in almost all parts of the world. In advanced level, and perhaps maybe international foundation year like those in the UK, here in Nigeria, you talk about level. Is that okay? Since the network is a bit disturbing, let me boost it. Let me boost the network. Please, once the network. The network went. The network is really trying to mess up this morning. I'm trying to boost it as much as I can. Just stay on. Be patient. Like I say, anytime you connect to our classes, okay? Be patient anytime you connect to the class. When network messes up, all right, I'll try to boost. I'll try to boost. So you stay on. While trying to boost, you might be logged out automatically. Just stay on, okay? Once I am done boosting the network, you'll be automatically logged in. Okay, so I'm trying to track, what is happening from the camera. I'm tracking it. So that what happened yesterday wouldn't happen. I had already thought all these things. I thought all of them, thinking that, the class was on. Okay, let us move on, please. I am going to evaluate you with questions, okay? I will evaluate you with questions like Aditype Pratap, right? I hope I pronounce it well. Please ask questions to us as well after teaching. All right, I'm going to do that. So let us move on. So this is how we identify metals. Like I said, if the valence electron of an element is either 1 or 2 or 3, that element is a metal. So you come over here to the atomic structures I drew here. We have oxygen, atomic number 8. We have sodium, atomic number 11. Aluminium, 13. Chlorine, atomic number 17. So which of them is a metal? Using the knowledge of valence electron. First, oxygen. Is oxygen a metal? No. The valence electron of oxygen is 6. I will follow up the network seriously this morning. I'll monitor everything about it. Okay, I'll monitor everything about it and boost it once it goes down. Let me see. All right. So we move on once again. Sodium. Is sodium a metal or not? Yes, sodium is a metal. You can see the valence electron 1. In the electronic configuration, the last number there is the valence electron. I'll say that once the valence electron is 1 or 2 or 3, that guy is a metal. So sodium is a metal. What about aluminium? Take a look at aluminium. This is aluminium. All right? So is aluminium a metal or not? Aluminium is a metal. Look at the valence electron of aluminium. The valence electron of aluminium is 3. Is 3. So it falls under this definition. So aluminium is a metal. You see how the knowledge of valence electron is guiding us. Now finally, what about chlorine? Is chlorine a metal? No. Why is chlorine not a metal? Look at it, 7. The valence electron is 7. Okay, so chlorine is not a metal. And you see, this whole idea of knowing the valence electron is simple. Once you know how to draw atomic structure, which is key to any student, it's a matter of fact from grade 9, a student should actually learn how to be able to draw atomic structure very well. Because from that grade, okay, we talk about the first 20 elements is taught in integrated science. So that is not a problem. And if you know the rule, the first share carries a maximum of 2, the second share carries a maximum of 8, the third, fourth, fifth, down to 7 share carries maximum of 8. You can actually analyze this atomic structure as fast can be. In fact, in a split second. Yes. And get the electronic configuration without wasting time. Okay? So we have found out that sodium is a metal using the knowledge of what? Valence electron. Aluminium is a metal using the knowledge of valence electron. I'm going to give you an assignment, please. Okay? The element calcium. The element calcium, by now you ought to have known your first 20 elements. Okay, at least within the limit of our elements. The first 20 elements are key for foundational learning. Calcium is atomic number 20. Is calcium a metal or not? This is a question. Anyone can drop the answer here. All right, you can drop the answer. Calcium is atomic number 20. Is it a metal or not? Now let us move on to the next importance of valence electron. Identifying nonmetals from valence electrons. How can the knowledge of valence electrons help us to determine an element that is a nonmetal? Now you have the short note here on the board. If the valence electron of an element is 5, 6, or 7, you know, I use all these fingers like I said. I understand sign language, both American Sign Language and Nigerian Sign Language. So sometimes I'll be using my finger to identify the numbers. So if the valence electron of an element is 5 or 6 or 7, that element is a non-metal. I hope I've communicated. So back here, once again, the element oxygen, is it a metal or non-metal? Now you know how to identify metals from valence electron. So I can use the concept of asking whether it is a metal or non-metal. Okay? Oxygen, is it a metal or non-metal? And clearly you would agree with me. I can feel you, yes, smiling and saying, yes, oxygen is non-metal. Because the valence electron here, as you can see, is 6. The valence electron is 5 or 6 or 7. That element is non-metal. So oxygen is non-metal. Now what about chlorine? Look at chlorine. Is chlorine a metal or non-metal? And you would agree with me that chlorine is non-metal. Chlorine is non-metal because the valence electron here is what? 7. The valence electron here is what? 7. So you see how important the knowledge of valence electron is. Dear friends, I am appealing to you, and I have said this, I think, in the startup class yesterday before network interrupted. Even educators, please, if this lesson from GMAT 41, if you come across it, I am appealing to you, even as an educator, a teacher, if you are, a lecturer if you are, when teaching atomic structure, please give it the best, because this actually takes there about 50% of chemistry, basic inorganic chemistry, for a student to understand this subject. Is that okay? And you, dear student, please, when you are being taught this topic or when you are studying it, give serious attention to it. There are about 6 parts of atomic structure, which I've split. It's going to take us there about 3 weeks or even up to 6 weeks, because I intend taking each part 1 week, since I'm meeting you per subject once a week. Tomorrow now I'm coming on live for physics. On Monday, 8 p.m. maths. Wednesday, 8 p.m. Nigerian time, West African time, 8 p.m. Wednesday for chemistry. I shouldn't be on live now. It's because of what network did yesterday. Okay, then on Friday, I come on live to take you physics. Tomorrow in our physics class, 8 p.m., I'll be dealing with scalars and vectors. Okay, so talking about this concept of atomic structure, there are about 5 or 6 parts of it, based on the curriculum development that I worked on to give the best understanding, to students in this aspect of chemistry, and hence about 50% weight of chemistry. So make sure you stick around. Like I said, if you have not subscribed, do yourself good, subscribe. And don't just subscribe, or turn on the notification bell. After clicking on the notification bell, okay, select all, so that you will always be the first to receive a notification from YouTube once our class is on, or if I upload any pre-recorded video. Now, chlorine is non-metal, like we've identified. Is that okay? Chlorine is what? Non-metal. Now, someone has answered this question. Will Gear, calcium is a metal. You are very correct. We'll come back to that after asking you the second question on non-metal. Now, I have this question for you. Nitrogen, phosphorus, are they metals or non-metals? Nitrogen and phosphorus. Okay, you can use any one of them, because any one of them can help you interpret the other one. Nitrogen and phosphorus, are they metals or non-metals? I'm going to help you out, at least giving you a hint. Nitrogen is atomic number 7. Phosphorus is atomic number 15. So are they metals or non-metals? What is your answer? Use the knowledge of valence electron to answer that. By the way, Will Gear said that calcium is a metal, and that is absolutely correct. So here it is not a matter of cramming. Oh, which element is a metal, which one is a metal? From your basic introduction to chemistry, you should learn all of these things, because atomic structure exposes all these secrets to us. The key subtopics, parts in atomic structure, they expose all these secrets to us. The electronic configuration of calcium is 2882. Once again, 2882. That is the electronic configuration of calcium. You see that the last shell, the valence shell, contains 2 electrons. So the valence electron of calcium is 2. Because the valence electron of calcium is 2, it means that calcium falls under this definition of metals. Hence, calcium is a metal. Calcium is a metal. So what do you have to say about nitrogen, about phosphorus? I'll give you a little moment to see if anyone will drop the answer before we now move on to how to use the knowledge of valence electron to determine the group, to identify the group of an element. And it's important for you to know that when you talk about group of an element, period of an element, this is a topic, a concept that is well established under periodic table. And periodic table is a topic that is being taught at grade 11. Here in Nigeria, SS2. In chemistry, periodic table happens to be, yes, the first topic taught in SS2. So do you see, even from grade 10, SS1, the student would have gotten, in fact, 70% knowledge. I repeat that again, 70% knowledge of periodic table. It's all about the educator, the teacher, establishing atomic structure properly, the way it is meant to be. So you have the question there, is nitrogen and phosphorus, okay, are they metals or non-metals? Please, your answer quickly. Drop your answer. Drop your answer. Calcium and phosphorus, are they metals or non-metals? Be fast, please. This class will be far less than 1 hour class because it's just a conclusion of the 33 minutes or the 34 minutes class of yesterday. The whole class on this topic is meant to be 1 hour. So be fast. We're already like 20 minutes or so gone. Nitrogen, phosphorus, are they metals or non-metals? This is the knowledge of valence electron. Nitrogen is atomic number 7. Phosphorus is atomic number 15. From the atomic structure, you can actually answer the question without wasting time. And like I said, one can analyze the electronic configuration, you know, and from it quickly you get your answer as to whether it is a metal or non-metal. Nitrogen is atomic number 7, like I said. That's good. So nitrogen, that's atomic number 7, is a non-metal. How do we know that it's a non-metal? The electronic configuration is 2,5. So the valence shell, the outermost shell has 5 electrons. And because the outermost shell has 5 electrons, it falls under this definition of non-metals. The valence electron is 5. So nitrogen is non-metal. Let's talk about phosphorus. Phosphorus is also non-metal. Of course, the valence electron is 5, the same as that of nitrogen. Okay? You are going to find out why they are the same per se. In fact, when you come to periodic table, there is something about their group number you should know. Electronic configuration of phosphorus. Okay, wheel gear. Nitrogen is a non-metal. That's correct. Nitrogen is a non-metal. Remember this class I am teaching. I usually host a special class for question and answer. Yes, where I will quiz you. In that case, I won't show the board. Okay, I'll have the questions already and they will be appearing. I'll use screencast. I'll cast my screen so that you see the questions and I'll dictate it, you answer. So by the time I ask a question and I give a little moment, if no response, I will step in so that we don't over waste time. So phosphorus, atomic number 15. Can someone say something about it? Well, here is good. It's good having you, attempting the questions. At the end of the class, something may happen. So make sure you are part of the class. Make sure you contribute to the class. If you look at, we have leaderboard in our contribution. If you're contributing to the class by answering questions, by asking questions, we'll have leaderboard. And someone may get rewarded, yes, at the end of the class, depending on how well the person contributed to the class. Phosphorus, atomic number 15, is it a metal or non-metal? Your time is almost going up and I would give a response to that. Sometimes what I just give a little moment is I know that at times network may disturb even you from that end. It's possible. Phosphorus. So is it a metal or non-metal? Good. So phosphorus, atomic number 15, is non-metal. The electronic configuration is 2,8,5 if you draw the atomic structure. But you don't need to draw the atomic structure. You can always analyze this. The first shell can contain a maximum of 2. The rest shells contain maximum of 8. And you know you can only add a new shell if a particular shell electron number is maximum. All right, so if phosphorus is 285, it means that the valence electron is 5, and hence phosphorus is a non-metal. That's good. So we have been able to use the knowledge of valence electron to identify elements that are metals and the ones that are non-metals. Take note, at the end of the class, I'm going to ask you a question. I have these questions from professional exam body, all right, in Nigeria here, like this JAMB questions here, all right. You know, in Nigeria, JAMB is one of the considered professional exam. We have WAEC also, we have NECO, we have NAPTEP. Are you following, right? NAPTEP for those in technical school. So I have these 3 questions and I'm going to evaluate you on at the end of the class. Let us move on to the next thing. We are going to look at how to use the knowledge of valence electron to identify the group of an element. The group of an element. In periodic table is simply the arrangement of elements in groups and period. A table that shows the arrangement of elements in groups and what? In periods. Now, the knowledge of valence electron can help us to identify, to determine the group that an element belongs to in periodic table. So if you know the valence electron of an element, you have actually known the group that the element belongs to. Here you have the short note covering that rather. The group that an element belongs to in the periodic table is the valence electron number of that element. Is the valence electron number of that element. So I can ask you, an element X, atomic number 15, belongs to which group of the periodic table? Once again, an element X, atomic number 15, belongs to which group of the periodic table? Now, in that question, you really don't even need to identify what X is. It's not necessary, since the examiner has already told you the atomic number of that element. In our previous class last week, where I taught you the concept of the relationship between mass number, atomic number, and neutron number, I told you that atomic number is the same as proton number. And for an atom, because an atom is considered to be electrically neutral, it has not reacted, atomic number there will be the same as proton number, will be the same as electron number. So once an examiner has given you atomic number, the examiner has released a lot of information to you. Okay? So if X is atomic number 15 and you are asking which group it belongs to, simple. From that atomic number 15, it means that the atom X or the element X has 15 electrons. Therefore, with the knowledge of electronic configuration, you getting the valence electron, your problem is solved. You know, with 15 electrons, that's going to be 285. The last electron is 5. So the valence electron of X is 5. Therefore, X belongs to group 5 of the periodic table. Okay, now, listen to this question. An element Y has a valence electron of 2. The element belongs to group dash of the periodic table. Since the examiner told you that the element Y has a valence electron of 2, it simply means that element Y belongs to group 2 of the periodic table. Now, instead of giving you the valence electron directly, an examiner could have asked you this. The atomic number of element Z is 12. The atomic number of element Z is 12. Z belongs to dash group of the periodic table. With atomic number 12, alright, the valence electron will be 2. Why? Because atomic number 12 has 12 electrons. And so if you distribute that 12 electron according to electronic configuration, all this is easy, okay? You're going to get 2, 8, 2 as atomic number 12. 2, 8, 2. That will be the electronic configuration. The last number is 2, which is the valence electron. Therefore, the element is in group 2 of the periodic table. Because in this case, Z, which is atomic number 12, as the examiner asked, is actually magnesium. So you can see that with knowledge of valence electron, you can be able to identify the group of an element easily without any waste of time. Darcy Mitchell, hi, you're welcome to join the class. And I hope you are fine. That's good. Now, let us look at the concluding part of the class. How do you identify the period of an element? Although this one does not come, it doesn't come from valence electron directly anymore. But I have to introduce it here because, of course, I also brought that fully in one of our class, okay, from last session, 2024-2025 session. Just before the last professional exams that were taken in the country, Nigeria, before WAEC nickel, jump, naphtha. How to atomic structure should no longer be your problem. If you have not learned it, please go and take the lecture on atomic structure on this channel. It's under the live session of this GMAT for the ones channel. So you learn how to do all of this, because this is where the weight of chemistry hangs. So you don't joke with it. Is that okay? You don't joke with it. Now, how do you get the period of an element? The period of an element is simply obtained from the number of shells the atom of that element has. So from atomic structure, how many shells does that element have? How many shells does the atom of that element have? Once you know the number of shells that the atom of an element has, which of course you get that from the atomic structure, you have automatically known the period that the element belongs to. Now in the exam hall, if they ask you the period of an element, would you now start drawing the atomic structure of that element? That's a waste of time. The network of your brain, when activated, just like the GMAT 41 always acts to activate it for you. Yes, I help you to think wide, far, to send out the network of your brain and capture information that you would use for your analysis. These things are simple to do. Just make sure you always tune in to GMAT 41's classes. I will open your eyes to all these things. Just one little thing can actually give you as high as 50, 60, 70% knowledge of a whole thing. One little key point, secret put out can expose a whole lot of things for you. Is that okay? Think of maybe when you talk of people that investigate something. People that investigate. Most times they only need one little idea, one little secret. And from there, they start exploring a whole lot of possibility, and you see the right information coming to them. The same thing with our learning. It is important for a student to understand that each topic you treat has a fundamental secret. And once you're able to capture that secret, boom, that is how you conquer that topic. And who knows, by extension, you may have even conquered that subject. And here at GMAT 41, remember I told you this 2025-2026 section, once I come on live, anything I put out, I'll be hitting and emphasizing and re-emphasizing these key secrets per topics, per subject, so that you can conquer this subject as well and love the subject. Not when as a science student, when they ask you what is your best subject, you have maths there, you have physics, you have chemistry, you have biology. You wouldn't talk about them. Those ones wouldn't be your best subject. You'd be telling somebody my best subject is CRS. My best subject is home economics. My best subject is home management. My best subject is data processing. Okay, data processing, but it's not fundamental for science fully. In academic world, what we know about science, okay, data processing is not fundamental of it. Or at worst, you tell us that your best subject as a science student is civic education. Why you hear this same called science student telling you I don't like chemistry, I don't like physics, oh gosh, I hate math. Why would you hate this core science subject and you claim to be offering science? Why telling us your best subjects are all these other subjects that generally have nothing to do with core sciences? Look at the higher institution. If you go to a university, when you talk any science related course, engineering, these courses are built on maths, physics, chemistry. Then biology for those in the medical field. Do not allow anyone to deceive you. Whatever curriculum anybody is putting out or whatever, please, your academic career is very important. Know what you want to aspire for and focus on all those key subjects. If you now want to expand anyhow to other subjects they introduce and other things, right? That will now be your choice. But make sure the 5 fundamental science subjects, if you're a science student, should be key to your pursuit in your academic work. All right? And here at GMAT 41, I'll continue to tell you this truth. so you get well prepared. So if you are one among the science students that will say, oh no, I hate chemistry, no, I don't like physics, there are too many calculations there, oh no, math, I don't want to have anything to do with math, and you're still pushing for science, please, starting from today and even before now, I've been talking about it, disembark from such thoughts. You're not helping yourself. As a science student, civic education should not be your best subject. It shouldn't. It shouldn't. Yes, it shouldn't. Home economics should not be your best subject. Otherwise, you might still think of changing your line of thoughts in terms of the career that you want to undertake in life. Please, let us be aware of this truth. Now, when you come to this science subject, the question is, are they actually difficult as we think sometimes, or as we make it seem? I understand that sometimes the fault could even be from some teachers, some educators, because sadly, as it could be, some of us don't even really understand the subject for what it is. But that is not enough reason for us to now start pushing off these key science subjects, which is what the whole world knows, right? Why we claim to be a science student. Here on this channel, you would get the best anytime, any day. Like I said, this is not just an online channel or whatever. This is an online school on its own. By the way, the GMAETS 41 has launched and established his physical school as well too. We see the need to go a step further to establish a physical school, a secondary school focused on senior secondary school students, sciences specifically, here at Oka, Anambra State. Yes, GMAETS 41 Special Science College. That is the school. We'll be kicking off this September fully with our first batch. If you want to learn, you want to speak, you want to breathe science, apply and register in our school here in Oka. All right, so let us conclude our class here. Wheel gear, group 5. Good, phosphorus is in group 5. So we're talking about the period of an element, and I told you you get it from the number of shells of that element. In the atomic structure, how many shells, right, does the atom of that element have? And without drawing the atomic structure, you can actually analyze the electronic configuration, like I said. So from the electronic configuration, you can know how many shells that element has, and hence the period it belongs to. We have this element, oxygen. It has 2 shells. So oxygen belongs to period 2 of the periodic table. From the electronic configuration, you can see it 2, 6. There are 2 numbers here in the electronic configuration. So from there, you know that this guy belongs to period 2. What about sodium? There are 3 shells there. Assuming this atomic structure is not there, but you know the electronic configuration, 281. How many numbers do you have in the electronic configuration? You have 3 of them, 2, 8, and what? 1. So since there are 3 numbers making up the electronic configuration, sodium belongs to period 3 of the periodic table. How about aluminium? Again, period 3, because there are 3 shells there. Electronic configuration is 283. Okay, so 283 is the electronic configuration of aluminium, so it belongs to period 3. Not because of these 3, not because of the valence electron. Here you don't use valence electron to interpret the period of an element. You only use valence electron to interpret the group, to identify the group of an element. For period, you use maybe either the electronic configuration or straightforward from the atomic structure. But I prefer an exam case focus on knowing the electronic configuration, because it can be quick to do that rather than drawing out the atomic structure. Now, what about chlorine here? You can tell yourself that it is period 3. Okay, let me ask you on this. Potassium belongs to period what of the periodic table? Potassium is atomic number 19. Potassium is atomic number 19. So what period of the periodic table does it belong to? And of course, from the electronic configuration of an atom, that's atomic number 19, you have the electronic configuration to be 2, 8, 8, 1. Again, 2, 8, 8, and 1. There are 4 numbers in the electronic configuration. Therefore, potassium belongs to period 4 of the periodic table. If you draw the atomic structure, you are going to see 4 shells there. And so this is how we use the knowledge of electronic configuration to identify if an element is a metal or non-metal, to identify the group of an element. And then finally, using the number of shells or simply the electronic configuration to identify the period of an element. And with this group and period, I've given you good knowledge, yes, very good knowledge of periodic table, because that's the starting point of periodic table whenever you are dealing with that topic. We are done with the application of electronic configuration in determining whether an element is a metal, a non-metal, and the group of their elements. For an element to be a metal, the valence electron will either be 1 or 2 or 3. For an element to be a non-metal, the valence electron will either be 5 or 6 or 7. The group of an element is obtained from the valence electron number. The valence electron number is the group that the element belongs to. And finally, I explain how to get the period of an element. Dear student, did you take note that I did not talk about elements with 4 valence electrons? I did not talk about elements with 8 valence electrons. There is a reason. These elements, we don't categorize them, we don't classify them as metals purely, and we don't classify them as non-metals purely, we don't. Group 4 elements, they are unique in a way. Group 8 elements, they are unique in a way. Now if you look at group 4, forms the boundary between elements that are pure metals and elements that are pure non-metals. If valence electron, if the number of electrons in the outermost shell is 1, 2, or 3, we classify that as pure metals. Now, before talking about non-metals, you found out that I jumped elements that have 4 electrons in their outermost shell. 4 electrons, I jumped that. And then I moved on to elements that have 5, 6, or 7 valence electrons. Those ones are classified as pure non-metals. So I know that someone out there is now asking, what about those that have valence electron of 4? What about those that have valence electron of 8? What about helium specifically? Because helium is also put in group 8 among the elements that have 8 valence electrons. Even though helium is atomic number 2, it has only 2 electrons. But because that shell is complete, the K shell for helium, you can draw the atomic structure on your own. Helium is atomic number 2. It has 2 electrons. If you draw the atomic structure, it has only 1 shell, which is the K shell. And that K shell is complete because it can carry only a maximum of 2 electrons. For that reason, we place helium in group 8, where the outermost shell of the elements are filled up. The structure of that helium is called duplet structure. Every other element that has completely filled outermost shell, we refer to them as octet structure. Octet, O-C-T-E-T. For duplet, it's D-U-P-L-T. Helium has a duplet structure. Every other element that the outermost shell is complete with 8 electrons has a structure called octet. Starting with neon, you have argon, and then you move on to krypton, you have xenon. But anyway, among the first 20 elements, we focus more on neon and argon, atomic number 10 and atomic number 18. All of these things, they come from the knowledge of valence electron. So you want to take note that elements that have 4 electrons in the outermost shell, that is, the valence electron is 4. There is something unique about them. We don't discuss them here. Let me tell you something. Organic chemistry is from which group? organic chemistry. Because of the unique nature of these guys, they form another aspect of chemistry called organic chemistry. Carbon is what we deal with often and more under organic chemistry. Carbon forms the structure of that part of chemistry. Carbon, the valence electron is 4, so it belongs to group 4. So you can see the unique nature. We don't talk about it. That's why sometimes you could hear some persons refer to that, those ones as metalloids. Metalloids, you know, they have behavior of metals, they have behavior of non-metals, they are just between. Now, if you move a bit further into certain knowledge of chemistry, like under periodic table, when we talk about the trends, the properties of periodic table using electronic configuration, is it using electronic configuration or electronegativity? Using electronegativity. If you come to that group 4, we can now say, okay, because of electronegative value, we can say that this particular one in group 4 that have 4 valence electrons can either be a metal, and then the other one can either be non-metal. Because electronegativity, then it decreases down the group and then increases across the period. Under periodic table, I'm going to teach you all of this. So because whether element in group 4 is metal or non-metal, we could say the ones above, they are non-metals, while the ones below, they are metals. But even at that, the fact that you cannot call elements with 4 valence electron, group 4 element, the fact you cannot refer to them as metals directly, the fact you cannot refer to them as non-metals directly, make them to now have this combined behavior, metal-like and non-metal-like. So generally we like, okay, metalloid. And like I said, their unique behavior is absolute in the field of science and engineering. Look at organic chemistry, it is carbon that is being studied. Now in physics, I remember last section before your professional exams, teaching the concept of semiconductors. Semiconductors, their valence electron usually are what? 4. Because there we pick silicon, we talk about silicon, we talk about germanium. Are you following, right? These are the 2 elements basically used as semiconductors. And you know, these guys are very important in the field of science. Okay, think of our chips that are used in computers and other things. A lot of semiconductors, they are used in it. Okay, think the US and the Chinese, they are top of this semiconductor production. So that group 4 is unique. That is why we can never talk about them as metals or non-metals. So I've explained the reason why you are not seeing elements with 4 valence electrons here. Okay, good. Now, what about those ones that have valence electron of 8? But remember, I mentioned helium that has valence electron of 2. But you can never say that helium is a metal. It's not. It is not. These 2 defined as metal here does not apply to helium. The reason is because for helium, that outermost shell is filled. The 2 that I have here, which defines metal also, is in a case where 2 is in the outermost shell, but the outermost shell is not yet complete. It starts with lithium, lithium, beryllium. Are you following? So in the case of beryllium specifically, in the case of magnesium specifically, in the case of calcium specifically, the valence electron is 2, but the outermost shell is not yet complete. Those ones, they fall under metal. For helium specifically that has valence electron of 2, it is not metal. We consider it under group 8 because the outermost shell of that helium is complete. And we have a name we give to them because all those elements there, they are gases. Elements in group 8 that have a completely filled outermost shell, valence electron completely filled as 2 for helium specifically, or valence electron completely filled as 8 for neon and for argon. These guys are gases. These elements, they are gases. In fact, we call them noble gases. Noble gases. Or we call them rare earth metals. But specifically, we call them noble gases. You can say noble, the bosses. Because their outermost shells are completely filled. Am I communicating right? They are completely filled. So you cannot refer to them as metals, you can't refer to them as non-metals. They have a special name given to them. Noble gases. Okay? Those ones, We don't classify them here as metals. We don't classify them here as non-metals. They are unique on their own as well too. All of them are monoatomic gases. Their valence electrons are mostly 8. Only helium has 2 valence electrons, and it is complete. The outermost shell is complete. Their structure can either be duplet or octet. You can never use this structure for either of metal or non-metal. Duplet or octet, only for elements that have completely filled outermost shell. Helium is one, which is duplet. Then the rest from neon, argon, krypton, xenon, like I said, they are octet in structure, because those ones have 8 electrons in the outermost shell completely filled. So I've given you that idea without writing it on the board. I hope you're able to put down some of the key points. If not, at the end of this lesson, a copy of this live class will be made available. You can come back, listen to it, and make a note of it, because an examiner can ask you questions on it. Nako, good morning, and hope you are doing fine. You're welcome to join the class. All right, friends, we are done with this, and we are done with this concept of electronic configuration. Soon I'll be teaching you the electronic configuration form that uses the concept of azimuthal quantum number, the concept of azimuthal quantum number and principal quantum number. All these 1s something, 2s something, 2s something, and then 2p something, 3s something, 3p something, that order. Okay, that form of electronic configuration. The electronic configuration I just treated here is shell electronic configuration. This one I just showed you that uses SPDF is subshell electronic configuration, because we obtained that guy from azimuthal quantum number, where we make use of subshells. Don't worry, that has nothing to do with this class. It's a different class on its own. Is that okay? We are focusing on valence electron and its application, its importance. You've learned how you use it to determine or identify metals, non-metals, and group of an element. Okay, and we talked about for those that belong to group 4, where you get your organic chemistry from, you get your semiconductors from, they have valence electron of 4. We talked about the ones that are called noble gases, or using the knowledge of valence electron. For period, we use the knowledge of electronic configuration, or the number of shells. As we conclude this class, I'd like to tell you what we are going to meet next week in our chemistry class. We are going to use the knowledge of valence electron this time around to determine, to identify the valency. I didn't say to identify the valence. To identify the valency, CY. And as well as correct chemical formula of a compound. I repeat that again. The use of valence electron to determine the valency of an element, as well as correct chemical formulae of a compound. How can the knowledge of valence electron help us there? Don't miss out that class, because that class is going to be very, very important. Some of our science students today in chemistry don't even know how to write correct chemical formula of a compound. Mind you, I said some, I did not say all. Of course, I have seen. Yeah, I've seen. So I'm speaking from experience. So from that class, you are going to learn that the knowledge of valence electron is going to help you, or can help. Is going to, or can? No. Let me be blunt in it. The knowledge of valence electron is what you will use to understand, okay? Is what you must use. You must know to understand the concept of valency and how compounds form, so that you can write the correct chemical formulae of a compound. Let me assume that I said you should write potassium. Okay, let me give you this tough one. If I tell you to write the chemical formula of the compound, sodium heptaoxodichromate 6. Sodium heptaoxodichromate 6. Or I ask you to write the chemical formula of ammonium tetraoxosulfate 6. or I ask you to write the chemical formula of lead-2-trioxonitrate 5, or I ask you to write the chemical formula of zinc trioxocarbonate 4, how can you do this? Don't miss our next class. Once again, we are going to use the knowledge of valence electron to expose that topic. Only one thing is destroying a lot of things for you, simplifying a lot of things for you. Valence electron. Chaka Buhar. Brother, tell me about United Electrons. You're funny. All right, please. I have these questions for you. You can answer them. You can come back. At the end of this class, like I said, a copy of this lesson will be made available. So you can come back and drop your answers below in the comment section. Okay? And you can also make use of our channel community. Please listen and listen good. The channel community helps you to interact with me directly. So if you come to the homepage of this channel, you'll see visit community. Tap on that visit community, and there you can send message just like you interact on social medias. Or you can, if maybe I give an assignment and you have solved in your book, you can snap it and upload it directly to GMAETS 41 through that community. So you see that what YouTube launch regarding the channel community is wonderful. I have these questions for you. Okay, I have these questions for you. Let me see, where will I wipe? I think I can now wipe this. Can now wipe this. Can now wipe this. Can now wipe this. Because the note continues from our last class. So we have these questions. You have to answer them. Questions. There are 4 questions, or 3 questions. Number 1, I won't copy them on the board fully because space will not be enough. I'll dictate it. Number 2, and then number 3. Number 2, and then number 3. So this is the first question. Question number 1. 4 elements. 4 elements. P, Q, R, and S. 4 elements. P, Q, R, and S have atomic numbers of 4, 10, 12, 14, respectively. Don't mind my finger. This syndrome of sign language has entered me this morning. I don't know. Okay. 4 elements P, Q, R, S have atomic numbers 4, 10, 12, and 14, respectively. Which of these elements is a noble gas? Which of these elements is a noble gas? Remember the concluding part of our class, of my teaching in this particular class, where I told you something about elements that have 4 electrons in the outermost shell. That is group 4 elements. I talked about they form organic compounds, they form silicon, so they form semiconductors. And then I now talk about those that have completely filled outermost shell. And I mentioned the concept of the duplet and the octet structure, So you can replay that to be able to answer this question if you are confused. 4 elements P, Q, R, and S have atomic numbers of 4, 10, 12, and 14 respectively. Which of these elements is a noble gas? Which of them is a noble gas? A, P, B, Q, C, R, D, S. Which one is a noble gas? Which one is a noble gas? All right. If you feel like I can be answering your question if you want, continue with the next class. I can't continue the next class, Will Gear. We have a timetable, and I respect timetable a lot. On this channel, the network just went down, but I've boosted it. Let's see. I've posted the network. All right. So let's see, it's a bit blurred, let it come up. So someone had dropped the answer, wheel gear, element Q, element Q, because it has an electronic configuration 28 and it is neon. Correct. Correct. So the noble gas there is element Q, because Q is atomic number 10, electronic configuration is 28. Okay, so 8, the atomic share is complete, and that's good. All right, wheel gear, you're going to do something because you've contributed to the class a lot. You do something for me because GMAETS 41 has recognized and has approved to reward you with 500 units airtime. 500 units airtime. I don't know where you are, where you're connected to this class from, but whatever it is, thanks to God for technology. Look at this number, +234 8064462385. Send your full name, listen, your full name, where you reside, where did you connect to this class from, which country, and states. If it is in Nigeria, you can just mention the states. If it's not in Nigeria, you mention the country, okay? Then indicate the network you wish to be credited. Now, if it is not in Nigeria, perhaps I may not have a network. So we'll find a way around it. Let's know how you can claim your reward. The reward will go for 500 unit airtime, which is equivalent to Nigeria 500 naira. So however it is, we know what we're going to do so you can get it. Okay, Will Daniel. Is it Will Gear rather? Will Gear. All right. So you have to mention your personal name and link it to this Will Gear. I will confirm if you are the one. So for others, don't even attempt to send me any message. I would definitely confirm the person before I reward the person. Is that okay? So Will Gear, take note, right? I'll be waiting for that just after this class. Does that make sense? I'll be waiting for that just after this class. You can also type, you can indicate here where you connected to this class from. Please indicate here, type it. Type it, Will Gear, where did you join this class from? So that by the time you're sending a message, I'll also link it up to this, right? Let's move on to question number 2. We are concluding the class. Our time is up already. Our time is up. I'm just trying to dictate questions you have to solve. Question number 2. 4 elements, P, Q, R, and S have 1, 2, 3, and 7 electrons in their outermost shells, respectively. I read that again. 4 elements, P, Q, R, and S, have 1, 2, 3, 7 electrons in their outermost shells, respectively. It's just the same as their valence electrons, of course, because that's what outermost shell electrons are. The element which is unlikely to be a metal is, that grammar simply means the element which will not be a metal. The element which is not a metal in PQRS is which one? Which element is not a metal? That's just the interpretation of the question. Okay? The element which is unlikely to be a metal is option A. Option A, P. Option B, Q. Option C, R. Option D, S. These are questions extracted from professional exam body. But of course, whenever I use that professional exam, it's just to give them the respect for what they are. All right? When you come to the exam question, it's not as if there is anything in the exam question that made it out of the world because it is coming from a professional exam body. The questions they ask you are within the range of what you are meant to learn, which are the things that GMAETS 41 is teaching you. So never you think that, oh, is this how simple the questions are? No. These are the things they are meant to ask you from topics like this. Okay? The last question. 4 elements, W, X, Y, and Z 4 elements W, X, Y, and Z have atomic numbers. Take note. Have atomic numbers 2, 6, 16, 20. 4 elements W, X, Y, and Z have atomic numbers 2, 6, 16, and 20 respectively. Which of these elements is a metal? Which of these elements is a metal? Which means all of them are non-metals except one. So which one is a metal? Option A. This is the last question, take notes. X. Option B. Z. Option C. W. Option D. Y. So which of these elements is a metal? Nako, shout I love this dude, and I hope that the channel is giving you the best. Right? No, network would always try to do its own, but we would never give up. If you give up, you will never be able to do it. If you give up, you will never know how strong you are. So GMAT 41 here, and you friends who are GMATs, yes, we don't give up. We don't give up. We have conquered the network for a class today, and that's wonderful. All right, so I've dictated the questions and written the options for you so you can answer them. SH for Shankar, Y, mention Y. I think which one is the question asks. 4 elements W, X, Y, and Z have atomic numbers 2, 6, 16, and 20 respectively. Which of these elements is a metal? Which of these elements is a metal? Yeah. D, option D is Y. The metal here is Z. The metal here is Z because Z has atomic number 20. Z is atomic number 20. Okay. In this option here, Z, from what they gave to us, W, X, Y, and Z. Z is atomic number 20. So if you use the electronic configuration, check the valence electron, you find out that Z is the correct answer here. Okay, not Y. Wheel gear, correct. You got the answer, element Z. That's good. And it is calcium. And you see, we covered all of this in our class today. So thank you for joining this class. And I hope to see you, friends, tomorrow in our physics class, 8 p.m. Take note, this particular class I held this morning from Nigeria here, I was not supposed to hold this class. I don't come on live today on this channel. I don't. I come on live on Mondays, all right, on Mondays, on Wednesday, and on Fridays. Time, 8 p.m. in the evening, Nigerian time. 8 p.m. Nigeria time, West African time. So if you are not in Nigeria, you can get the equivalent of 8 p.m. from Nigeria. Get it in your own country so you know when to come on live. But by the way, like I've always said, to also help you out so that you don't overstress yourself, subscribe if you have not yet subscribed, turn on the notification bell and select all. Anytime I come on live or I upload any video, you will be the first to be notified by YouTube. In our next class, we will see how, that is next chemistry class, which is next week, Wednesday. We'll see how valence electron knowledge can be used to determine the valency of an atom as well as correct chemical formula of a compound. But tomorrow, like I said, according to our timetable, 8 p.m. in the evening, Nigerian time, like I said, we are going to be taking on physics, scalars, and vectors. Have a wonderful day. Remember, you can support GMAT 41 either because channel member on platinum or diamond level, that's a monthly package of 2,000 naira or 4,000 naira. You can also send us super stickers, super thanks. That one is just one-time support. If you click on the thanks icon on any of our video, thanks icon below any of our video, YouTube will bring out, certain super chats or super thanks amount you can use to support this channel. So I will keep moving on. Are you following, right? Then whatever that is convenient for you from there, you can just use it to support GMAETS 41, and I would really appreciate. Okay, I really appreciate. Thank you once again for connecting to this class. Invite your friends for our class tomorrow. Bye. We'll get more questions, don't worry. I'll meet you in our next class, okay? But I love your commitment and your determination, okay? Make sure you stick around. Learning is a process. So gradually, we can't learn everything one day. Today's zone is sufficient with regard to what I want to cover. Bye once again. Remember to send me your details, Wave Gear, on WhatsApp for your reward because of your contribution to today's class.